Hi everyone, welcome back to Three Inquisitive Kids. On this channel, our purpose is to level up your math capabilities no matter who you are, and to create a curiosity to explore more in the world of mathematics. Now, in case you don't know yet, my name is Karen, and I will be teaching the 8th grade Chapter 6 series. In Chapter 6, we will learn all about means, medians, and modes, and learn how to analyze data set from charts and graphs. So let's dive into our first lesson, means. Learning about means and how to find them. So as you can see, this is the course outline of Unit 6. So we have our first lesson here, means, median and mode, analyzing the central tendency from statistical charts and statistical dispersion. The two learning goals of today is to grasp the concept of arithmetic means and weighted means, and be able to calculate the arithmetic mean and weighted mean of a set of data. Can use the arithmetic mean and weighted mean to solve word problems. Observe and think. As you can see, there is a graph here, and in the lines blue, purple, and red, those show the shooting results of A, B, and C. So maybe they are practicing with a bow and arrow, who knows? Who has better results and who is more stable in their results? How do you determine this? In addition to the intuitive feeling, so in addition to your instincts by just looking at it, how can we use quantitative data or math to describe the keywords better and more stable? So let's first look at this graph, and as you can see, there is a blue line, pink line or purple line, and a red line. So the higher up you are, the better score you got. As you can see, they all shot 10 times. And each point here shows the result of that one go at their shooting. So let's first look at blue. So this blue line here, as you can see, it starts off pretty well, doing better than the others, and then it goes up a little bit more, and then it drops down massively. There's another spike, and then it goes down again. Finally, it goes up, and then again, it's sort of the same after that. As you can see, in the blue line, there's huge sudden spikes of ups and downs. So that's what it means when it says more stable. This is an example of unstable data values because there's so much sudden ups and downs that it's pretty hard to find a pattern. The purple one here, as you can see, is more stable because it doesn't have that much changes around it. And if I were to draw a line through it to kind of show what it's like, you see that this line more accurately, so this graph, this purple graph right here, can be more easily drawn as a line. It's pretty hard to do that with this blue one here since there's so much change. So since the higher up you are, the better you are, we could say that the blue one here does pretty well because, at least in the beginning, because it's higher than all the others. But then it drops even below so that here on their 5th turn, blue does pretty badly. So who is better? Well, pink or purple does pretty well. It's pretty high up and more stable. So sometimes very precise stuff like this, you can't exactly just tell by looking at it. Sometimes you need to have precise calculated equations to help you solve this. So that's what we're going to learn today with our knowledge of averages and means. Arithmetic means. Whenever you hear statements like Combin's height is above average in his class, so Combin is another recorder we have on this channel, or the members of basketball team A is overall younger than basketball team B, etc. What do keywords such as above average and overall younger than mean? How do you make these judgments based on sets of data. So in mathematics, we often use mean, median, mode, and range. So these are all statistical key terms to analyze and describe data. So its purpose is to analyze and describe data. Think. What are factors that affect the performance of a sports game? How can you measure the average height of both teams? So as I'm talking, I want you to be thinking in your head. How can you understand players from team A are taller than players from team B? So how can you prove that? How did you get this conclusion? What data would be needed to compare the heights of players on two teams? Well, the factors that affect the performance of a sports game are, I'm not particularly I don't particularly watch sports or anything like that, but if you know lots about a sport, I'm sure there's stuff like, stats and all of that. How can you measure the average height of both teams? The average height. Okay, keyword is average here. Average, what does average mean? It means what usually since there's lots of players on both teams, and on each team, each probably has a different height. How do we come up with a conclusion that's only one number that can overall describe the height of both teams? So average, so mean, mode, and median are all different ways to describe average. Okay, and we haven't really delved into that yet, but we will quickly in this lesson. So yeah, stay tuned. How can you understand players from team A are taller than players from team B? Well, we're essentially using the average of team A and the average of team B, and then we're comparing those two averages instead of comparing each player on each team. What data would be needed to compare the heights of players on two teams? Of course, we need to find their average, but to find that, we need to find the heights of each player first. Okay, so we have sports team A and sports team B. Think, which team has taller players? Which team has younger players? And how do you find this? Discuss. What about so let's first look at their heights. The heights here, we have some in the 200s. This is by, I think it must be by centimeters, I'm thinking. So there's the lowest we got. The lowest we got was 175. Okay? But as you can see, on team B, there is a lot of much taller people. Right? We see more in the 200s here, and their lowest I think is in the 180s. So 180 is their lowest score. So based on height, team B here is a runner up is taller. But what about their ages? Let's look at their ages. So the age of sports team A, its oldest was 35, but there's plenty of 19s and 22s as well. But we see a more drastic change in sports team B, where you see two in the 30s, and lots of these are around in the 20s area. There's not as much younger people. So a lot of these are above 25 years of age or are at 25 years of age, meaning that sports team A is younger. And usually when you're younger, you have more energy, you're stronger. So it might make sense why sports team A was the champion and sports team B was second place. Kaylee is surveying the ages, so Kaylee is another recorder on this channel. Kaylee is surveying the ages of team members of a certain sports team. Her records are as follows. So we have the ages, and over here it's showing us how many people have that age. For example, this means 4 people are 22 years old, 2 people are 28 years old, so and so. So the average age in years, and now this is where we start calculating the mean. We first add up all of these ages. And you see how there's 22 times 4. Why is there a times 4? Well, that's because there's really 4 people that are each 22 years old. So you have to count 22 4 times. You count 26 2 times, 28 2 times, 23 2 times, 29 2 times. You only have to count 27, 19, and 35 one time because there's only one team member that's 19 years old, 27-year-old, and 35 years old. So you first add that up. And then the divisor of this equation, you add up the number of team members. So the first is all of their ages divided by the number of team members. So you add all of these bottom row numbers up, you divide, and then you get 25.4 years. So their average age in years would be 25.4 years. Can you explain the reasoning behind Kaylee's calculations? What you can think of this is, say you have, how much people are on this team, for example? Let's look at it. You have 15 people on this team. And let's think about it this way. So 15 people are lined up, and each person has a number of, let's say, cookies that is corresponding to their ages. So for example, this 35-year-old would hold 35 cookies. This 19-year-old would hold 19 cookies. This 27-year-old would hold 27 cookies. So they all stand next to each other. And then what you do is you take all of their cookies away, and then you start distributing it evenly to everyone. All right, so that's what kind of mean is, to pull the highest to the middle part, that average. Our conclusion is that in everyday life, we often use means to find the average of a set of data. Usually from the set of n pieces of data, so let's say we have a data set, and in it there are n pieces of data, x1, x2, all the way to xn. We first add up x1 all the way to xn, and then we divide it by n. So this is called the arithmetic mean of the set of data, also called that. So this can also be called the average. Arithmetic mean. So this is the definition of the arithmetic mean. I highly suggest you take some notes or you screenshot this, and then we're going to move on to some problems. Arbor Day is here, and a certain unit organizes employees to carry out tree planting competitions. The graph below reflects the relationship between the number of trees planted and the number of people. So as you can see, there is a bar chart here. The x-axis is the number of trees planted, and the top, this y-axis, is the number of people that planted that amount of trees. First question, how many people attended the event in all? So here it's just asking for people, so you don't really need to look at the number of trees that they planted. All you have to do is look at how high each of these columns are and then add them up. So in this case, for example, this one is 1, 1 plus 8, 9, 9 plus 1, 10, 10 plus 10, 20, 20 plus 8, 28, 28 plus 3, 31, 31 plus 1, 32. So in all, 32 people attended. How many trees were planted in all? Now it's just asking trees. Let me first write this down. So 32 people attended the event. How many trees were planted? Well, now you have to multiply the number of trees to the number of people that planted that number of trees. For example, this is number 5. 5 trees planted. The majority of people planted 5 trees. 10 people planted 5 trees each, meaning that would be 50. So you do the same for all of these columns and then you add them up. And now how many people how many trees are planted per person on average. So now let's look at how we would solve this last problem. Okay, so we know 32 people. The total amount of trees planted was, you do some multiplication here, you have 155 trees, that's a lot. And the number of trees planted trees on average per people on average would be, so now we're taking is 155 trees divided by 32 people. So you would do 155 divided by 32, which is approximately 4.8 trees per person. Practice. In order to understand the age of the students, a class conducted an age survey, and the results were as follows. 8 students were 13 years old, 16 students were 14 years old, 24 students were 15 years old, and 2 students were 16 years old. Find the average age of the students in this class and round the result to an integer. So pause the video and use the methods we used for the example and the conclusion we had from the previous questions to solve this problem. All right, so there's a few main steps when finding means. First, you add, at least to find arithmetic means. Remember, we're finding arithmetic means right now. So first, we add all of those values up. So all of the ages we add up divided by the number of students. So this is approximately 14. So the average age of the students in this class, round to the nearest integer, it would be 14 years old. And as you can see here, X, it has a line over it. So it means that this is talking about average, and it's talking about the mean. Therefore, the average age of the students in this class is 14 years old. Now that we just covered arithmetic means, let's look at weighted means, its difference, and what it means. In practical problems or in word problems, the importance, this is a new idea now, a new concept, of each data in a group of data may not be the same. So now you're saying, maybe in a set of data I have, say, 1, 3, 7, and 10. 1, 3, 7, and 10. But I think that maybe the 3 should impact the mean more than the others because somehow 3 is of more importance. So this is when weighted means come in. So therefore, when calculating the average of this group of data, each data is often given a weight. So how much they weigh represents how much they impact or affect the final mean. I know this might be confusing. Let's look at the following example. So an advertising company is trying to recruit an advertising planner, and it conducted 3 quality tests on the 3 candidates A, B, and C. So these 3 people all want to be hired, and the company is conducting tests, 3 sets of tests on each of these candidates to compare them. And the results are shown in the table below. So let's look at this. Here we have the different tests on innovation, comprehensive knowledge, and communication. Over here we have their scores of A, B, and C. So this is A scores, B scores, and C scores. Now we have questions. Who would be hired if the decision was based on the average scores of the 3 test subjects? Well, here, basically we're being asked, this is asking us the arithmetic mean right here. For example, let's do A. So A did 3 tests. His score was 72, 50, and 88. So let's add those up. So that's 122, that would be 210. 210 divided by 3 would give us 70. So A's average score is 70. We do the same for B and C, and then whoever has the highest score, of course, would be hired. So the average score of A was 70 points, 68 points for B, and 68 points for C. Therefore, A would be hired because A showed the best performance in these 3 tests. But now let's look at the second question. According to the actual requirements that this job position needs to be successful in this company, the company will determine the test scores of each person based on the 3 scores of innovation, comprehensive knowledge, and language according to the ratio of 4 to 3 to 1. Now who will be hired? So now it's saying, essentially, if the ratio is 4 to 3 to 1, let me write this down, 4 to 3 to 1. Now, yeah, let's still look at A as an example. So if A so A got a 72 on innovation, the first test. And now this test is worth 4, but this is worth 3, and this is worth 1 out of the entire score. So what it's saying, this first test is the most important. So A here, A did, yeah, pretty well on innovation, so that's pretty good. And compared to the communications test, A did really well, and 88 is really well, but the 88 is not worth very much because the communications part in this ratio, it's only worth 1 when the other 2 tests are worth 4 and 3. So it would be more effective if A had gotten a better score on innovation and comprehensive knowledge. So A didn't do so well in comprehensive knowledge, but unfortunately that was worth 3 in this ratio, which is pretty much, that's a lot. But now let's look at B. And right now we're just looking at it. We're not doing any specific calculations, but you will learn how to do that after this. So let's look at B. B, out of all of his or her scores, 85 was the highest. 85 is really well. And B is lucky because he got I'll just go for he. 85 got a 85. B got an 85 on innovation, which is worth 4. So that has a big ratio. B also got a good score on comprehensive knowledge, 74. That's also, yeah, pretty nice. That was worth 3 in the ratio. And B didn't do so well in communication. But so this 45 here will not affect the overall mean so much because it's only worth 1 in this ratio. So now you probably sort of know what it means when it says weights and importance. Let's look at the solution. So A's weighted mean would be 65.75 points. And let's see how the slides did it. So A's first score was 72. And remember, the ratio is 4 to 3 to 1. So since A's first score was 72, so this 72 was multiplied to 4. The second score, 50, was multiplied to 3, and 88 was multiplied to 1. And then, of course, to divide by, and then for the weighted means, you have to divide by the total amount by adding these units in the ratio up. So 4 plus 3 plus 1 is equal to 8. So this is also different from arithmetic means. I want you to be paying attention. So that's why this is called the weighted mean of A is 65.75 points. Let's look at B, okay? So B scores, remember, let me draw another one here, was 85 for the first one, 74 for the second one, and 45 for the last one. So 85 is multiplied with 4 because that's what it's worth in the ratio. 74 is multiplied to 3, and 45 is multiplied to the 1, right? 4 to 3 to 1, that was the ratio we were given in the problem. And then we still divide by the total of these units in the ratios, 4 plus 3 plus 1. So the final answer would be 75.875 points. We do the same with C. And then in the end, we see that B actually has a higher weighted mean. B actually has a higher weighted mean. Therefore, if this was the case, B would be higher. 4, 3, and 1 are correspondingly the weights of the 3 test scores of innovation, comprehensive knowledge, and communication. So this equation here is the weighted mean of candidates' A scores. Let's look at another problem. Example 3. When the teacher evaluates the grades of the students every semester, he does not simply add a student's usual grades and the test scores and divide by 2, but calculates according to the requirement that the usual practice grade is worth 40% of the final grade and their test scores are worth 60% of their final grade. In this way, if a student's usual score is 70 points and his test score is 90 points, what should his overall semester evaluation score be? So what this problem is saying, so I guess the viewers are probably going to be, in secondary school, sort of, maybe in middle school, I don't know. But, when you're in school, sometimes the teacher might give you a evaluation guide, and it might say, attendance 20% of your final grade. This final exam, maybe it's worth 30%, 40%. So each of those things are worth different parts of your grade. And now this is saying that the usual practices in the homeworks and the worksheets that you do in class is worth 40%, but the test scores is worth 60%. And we know that the students had a usual score of 70 points and a test score of 90 points. So what is his overall semester evaluation score? Again, this is asking for a weighted mean. So let's look at the solution. Okay, the overall grades for the semester are, so this is, sometimes we have typos, so no worries, but this is supposed to be 40%, 40% instead of 30%. Okay, so this is equal to 82 points. So each of these, the 60% and the 40% are the weights, and this is the weighted arithmetic mean. So what is the meaning of weights? It reflects the different importance of each piece of data in a set of data. And the meaning of weighted arithmetic means is that according to the weights to reflect the mean of the set of data. Knowledge key point. Usually, if n pieces of data, so x1, x2, all the way to xn, each have a respective weight of w1, w2, all the way to wn, then this formula right here, so as you can see, x with the line over it, is equal to the top, we have each x1 multiplied to its respective weight, all added up together. Divided by, to the bottom here, is adding up all of these weights. Practice. 2 students' applications to a mathematics school are shown in the table below. Their scores from both the written test and the interview are included, and the weight of each score is shown at the top of the column. Based on this information, which student should be accepted? We have 2 applicants, A and B, and there are 2 tests. Written, 86, 92, that's their scores. Interview, A got 90 and B got 83. And we know, so this is also showing us that the written test is worth 60% of their overall score, and the interview is worth 40% of their overall score. So since both of those can be simplified further, the ratio is 6 to 4. So this is the weight ratio. First, the weighted means of students A and B. So the weighted mean of XA and XB are 87.6 and 88.4. Okay, so let's just look at A. A's first score on the written test was 86. That times 60%, which is the weight of the written test, and we add it with 90, which was the score A got on the second test, multiplied to the weight of that test, divided by divided by the sum of the weights. So we have 87.6. Because 88.4, which is the weighted average of B's score, was higher than the weighted average of A's scores, so B should be accepted into the school. Class summary. We learned all about averages, or should I say means, in this video. And we learned about arithmetic means and weighted means. We learned how to grasp the concept of arithmetic means and weighted means and was able to calculate the arithmetic mean and weighted mean of a set of data. We were also able to use the arithmetic mean and weighted mean to solve some word problems. So please comment down below if you found this video helpful, where it helped you, and if you still have any questions, also put it in the comments down below because we might be able to answer it. If you found this video helpful, please also subscribe because then you will be notified for the future videos we are going to post. So thank you for watching 3 Inquisitive Kids, and see you in our next lesson.